Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher, and today we are going to discuss the another next topic from the chapter atoms and molecules. Okay, and we are going to discuss about the molecules today. In yesterday's class also we have started discussing about molecules. In the yesterday's class I have explained to you how to find out the mass ratio. Let's have a quick recap of yesterday's class. Yesterday we have discussed how to find out mass ratio. Mass ratio is also called as ratio by mass, simply mass ratio or ratio by mass. Few examples I have taken in the yesterday's class for this particular concept. Now as I have told you already, this mass ratio is used to find out the simplest ratio of that particular elements are present in the molecule, right? Okay, what is the meaning of it? I'll tell you. Let us have the example of water. Okay, H2O is the formula for water. There are two elements present in water, hydrogen and oxygen. Okay, now let us see how to find out its simplest ratio. So let me just draw a table for that purpose. So these are the elements. Then first ratio by mass, or which is also called as mass ratio by mass or mass ratio, both the things are same. Then next is atomic mass, which is expressed in terms of U stand for atomic mass units. That's a unit for the atomic mass. Then we are going to find out the mass ratio divided by atomic mass. This thing we are going to find out, and this will give us the simplest ratio. Simplest ratio will decide the formula of that compound. Okay, so first of all let us write down for hydrogen. So I'll just revise the finding out the mass ratio for H2O. H2O has hydrogen and oxygen. So atomic mass of hydrogen is 1, as atomic mass of hydrogen is 1 unit, and atomic mass of oxygen is 16. Atomic mass of oxygen is 16 atomic mass unit, that is U. Okay, therefore the ratio hydrogen as to oxygen is equal to, there are two hydrogen atoms, so 1 multiplied by 2, and only one oxygen, so only 16. 2 as to 16, which will be simplified as 1 as to 8, right? 1 as to 8 is the mass ratio for H2O. Yes, so that I will write down here. So this is hydrogen and oxygen, 1 as to 8, right? Atomic mass of hydrogen is 1, atomic mass of oxygen is 16. Okay, then mass ratio by atomic mass, that is 1 divided by 1, it is equal to 1 for hydrogen, and mass ratio by atomic mass, 8 divided by 16, is equal to 1 by 2 for oxygen, right? 1 by 2 for oxygen. Now 1:1 by 2 is the ratio, right? What is the ratio? 1:2. Okay, new ratio obtained is 1:1 by 2. Okay, so what I will do, I will multiply both the sides by 2, so it will be 2:1, right? So what is the simplest ratio for water? It is 2:1, and therefore the formula is H2O, right? Okay, so this is how we have thus we have calculated the ratio of number of atoms for water. It is equal to 2:1, right? Okay, so I will conclude. I will write down the conclusion. Hence, the ratio of ratio by, not of, ratio by number of atoms, ratio by number of atoms for water is hydrogen as to oxygen equal to 2:1. Okay, yes, so this is how we yesterday we have discussed about the mass ratio, and that mass ratio is utilized or used for the finding out the simplest ratio of atoms. Okay, yes, just take a screenshot of this page first of all. Okay, so I hope you have taken a screenshot. Now after this we are going to learn about the different type of what you can say species formed by the atoms, and that is nothing but ions. Okay, yes, so I hope if any question is asked on the basis of this part, finding out the ratio of numbers, then you will be able to solve it. Okay, now let us discuss the next part in this chapter after the molecules, and that is nothing but the ions. Okay, so basically there are two types of ions. One is called as cation and another is the anions. Okay, cations are cations are positively charged ions. Cations are positively charged ions, whereas anions are negatively charged ions. Anions have negative charge on them. They are negatively charged ions. Negatively charged ions. Okay, so how these ions are produced, we are going to see. Okay, so first of all, let us see one simple example, and that is nothing but the NaCl, the salt which we use in kitchen. Okay, NaCl, that is sodium chloride. Okay, so I am going to explain how this NaCl molecule is formed here, so that you will understand what is the meaning of ions. Okay, yes, so in this NaCl compound there are two atoms. First one is Na, that is sodium. Okay, Na is nothing but sodium, and another is chlorine, right? Another is Cl, and that is nothing but chlorine. These two atoms are present in this compound. Okay, their atomic electron configuration I will write down. Sodium atomic number is 11. Its electronic configuration is 2. Okay, its electron configuration electron configuration for sodium is 2, 8, 1, right? 2, 8, 1, whereas the electron configuration for sodium, whose atomic number is 17, atomic number is 17, and electron configuration is 2, 8, 7, right? 2, 8, 7. Now always remember, every element in nature tries to get stability. Every atom of every element present in nature tries to get stability. Okay, how that stability is achieved? So stability is achieved by loss or gain of electron, or electrons, more than one electrons also, to get the completely filled electron configuration. Okay, if electron configuration is completely filled, that is whatever by the shell, that should be completely filled. Okay, if it is completely filled, that means stable configuration, right? Okay, in that context, if you observe the sodium metal, okay, in case of sodium metal, this is the K shell. In the structure of atom we have discussed all these things. Okay, this is the L shell and this is the M shell, whereas in case of chlorine also, this is K shell, this is L shell, this is M shell, right? So if you can see, in case of chlorine atom, there is one electron in M shell, just one electron. So if that sodium atom gives that one electron to someone, right? Electron cannot be given in the air, it should be taken by someone. Okay, so if that sodium is giving that one electron present in the M shell, then we will have 0 electron in M shell. Okay, 0 electron in M shell, and L shell will also be completely filled, right? L shell is completely filled because 8 electrons completely filled. Similarly, in case of chlorine, if you can see, there are 7 electrons in M shell. Okay, we know that if 8 electrons are there in initial, that is a completely filled configuration, right? Completely filled configuration means what? I will write down either duplet means 2 electrons, or octet, either duplet or octet completed, right? Octet means 8 electron, duplet means 2 electron. So to get to 8 electrons in the outermost shell, sodium needs to give out the or lose the electron, then there will be 8 electrons in L shell. Then in case of chlorine, 7 electrons it cannot lose, right? Because losing 7 electrons is really a big task. Okay, energy will be required, but it can gain 1 electron very easily, because just 1 electron it needs to gain. Therefore it has a tendency to gain electron. Okay, after gaining electron, 7 plus 8, there will be 8 electron. That means octet will be completed, right? Okay, so here sodium and chlorine, they are going to decide one thing, that is sodium will donate its electron, chlorine will accept that electron, right? Very simple thing is there, guys. So just assume that sodium and chlorine are friends. Okay, they are two friends. So they want to set up one industry. Okay, they want to produce something in their industry. Chlorine has ideas in mind, sodium does not have ideas in mind. Sodium has money to invest, chlorine does not have money to invest. So therefore what is going to happen, sodium will give its money, that is electron, to chlorine. Chlorine will accept that money, and then they are going to produce sodium chloride, that is the product, right? So this is the simple analogy here I can tell you. So the same thing is going to happen. Sodium is going to donate the electron, chlorine is going to accept the electron. So the same thing I will write down here. So what happens here, Na, in which there are Z is equal to 11, and there are 2, 8, 1 electron. Sodium is going to lose electron, right? So that lost electron, 1 electron will be here. Okay, and sodium will become, just a minute. Sodium is there, it is 2, 8, 1 extra electron is there, so that is going to lose that electron. So that electron, 1 electron I will write down here, and then electronic configuration will be 2, 8 only, right? No need to write down 0. 2, 8, 8 stands for octet is completed, right? 8 electrons in the outermost shell, that means octet configuration, right? Okay, but what happens to sodium here? Sodium has lost electron, right? Sodium has lost the electron, so electrons are negatively charged. That means we have taken out or removed one negative charge from sodium. That means sodium will become positive. So 1 electron is removed, so it will get 1 positive charge, right? So we are getting Na plus ion. Na plus ion is called as sodium cation. Okay, it is called as sodium cation, right? Cation means positively charged ion. Okay, yes. Now this electron which is given by sodium will be taken up by the chlorine atom, right? So for chlorine also I will write down. So this is your chlorine, in which there are 2, 8, 7 electrons. Then it will accept the electron donated by sodium, right? Okay, and then what will happen, it will become 2, 8, 8. Again octet will be completed. So this is your octet. That means chlorine also gets a stable configuration. What about the charge on chlorine? Chlorine has taken or accepted 1 electron. Electron are negatively charged, so there will be a negative charge on chlorine. Any charge on atom means that is ion. Ions are charged species. Positively charged cation, negatively charged anion. So Cl with the minus charge is an anion. The names are written like this. If it is chlorine ka anion, we'll write down it as a chloride ion. Chloride ion, negatively charged ion, anion ends with IDE. Okay, chloride ion. Okay, chloride ion is the anion here, right? Chloride ion is formed. If it is F minus, then it is fluoride ion. Okay, if it is Br minus, bromide ion, and so on. We are going to write down IDE at the end for the anion. Okay, IDE is for anion only. For cation, no IDE will be there. Okay, yes. So this is how these two ions will be produced from the this sodium and potassium. Now this Na plus ion and this Cl minus ion, both of them have the stable configuration, octet completed, right? Now they will come closer to each other because they are oppositely charged, right? Na has positive charge and Cl has negative charge. They come closer to each other and we are getting the product called as NaCl, that is nothing but sodium chloride. Okay, that is nothing but sodium chloride. So this is how the ions are produced. This is the reason ions are produced, to get the stable configuration, and once they get the stable configuration, they get converted into they are forming the chemical compound. Now here Na plus and Cl minus, they are oppositely charged ions, right? There are one is positive, another is negative. That means there is attraction. So there is a type of attraction in them. Na plus and Cl minus is attracted by a type of attraction. That type of attraction is nothing but chemical bond. Therefore we can say the type of bond, the type of attractive forces, I'll write down, the type of attractive forces in between Na plus, oppositely charged, right? Opposite attracts, Na plus and Cl minus. The type of attractive force in between Na plus and Cl minus is known as ionic bond. Okay, it is known as ionic bond. Very important, a very important type of chemical bond, ionic bond. Okay, type of attraction is called as ionic bond. Okay, and the compounds in which ionic bond is present are known as ionic compounds. Okay, are known as ionic compounds. Okay, ionic compounds, compound in which ionic bond is present are called as ionic compounds. Okay, yes. So this is about the ions, right? The atoms, when they donate or accept the electron, they are getting converted into ions. Okay, yes. So just take a screenshot of these pages. First of all, take for this. Now take a screenshot of this part, formation of this NaCl. I hope it is done. Now just like we have find out the mass or simplest ratio by mass for the uh, other examples like water, etc. Similarly, we are going to find the same thing for the ionic compounds also. Okay, let us see some ionic compounds, so and the ratio for them. So ionic compound, then the element present in them, that is constituting, or let's calculate it instead of that. Let us see how to find out the mass ratio or ratio by mass of ionic compounds. Ionic compound. Let us take the simple example first, and that is nothing but sodium chloride, NaCl, right? So here the atomic mass of sodium is 23, and atomic mass of chlorine is equal to 35.5, right? Therefore ratio Na:2Cl is equal to 23 as to 35.5. We cannot further simplify it. Okay, the next example, second example, is of calcium oxide. Calcium oxide, the calcium oxide formula is CaO. Okay, now atomic mass for calcium is equal to, I'll write down only Ca now, I will not repeat atomic mass word again and again. Okay, so for calcium atomic mass is 40 units, and oxygen is 16 units. Okay, therefore calcium as to oxygen ratio will be 40 as to 16. Okay, if I divide it by 8, okay, so if I divide both the numbers by 8, it will be 5 as to 2, right? So what is the ratio for calcium oxide? 5 as to 2. Third example, magnesium sulfide. Magnesium sulfide. Magnesium sulfide formula is Mgs. Okay, atomic mass of Mg, magnesium, is 24, and that of sulfur is 32. Okay, therefore ratio magnesium as to sulfur is equal to 24 as to 32. Okay, again here if I divide both the numbers by 8, right, so it will be 3 as to 4. Ratio is 3 as to 4 for magnesium sulfide. Then next example, fourth example I will write down, and that is magnesium oxide. Magnesium oxide formula is MgO. For magnesium mass number is 24, and for oxygen it is 16. Therefore magnesium as to oxygen ratio will be 24 as to 16. Okay, so 24 as to 16, here also I will multiply it by 8, so it will be 3 as to 2, right? 3 as to 2. So this is how we can find out the mass ratio for ionic compounds as well. Okay, yes, just take a screenshot of this page. Okay, I hope it is done. So in the next class we are going to discuss about the next part from this chapter, and that is nothing but writing down chemical formula of compound. Okay, so today we will stop here. Let me just tell you about the DPP daily practice problem. So this is the teacher's portal Here you have to go to resources, then to writing material, where you will see the DPP, daily practice problem. You can download it here. Write down the solutions to the questions on your notebook. Take a picture of your notebook photo and you have to upload it across, send it across, upload on the portal itself, so the teacher will evaluate and let you know the suggestions and corrections in it. Okay, so that's all about DPP, and today we are going to end the session here only. Tomorrow we'll discuss the another topic from the same chapter. Thank you so much students for your precious time, and all the best to you. Take care.